Okay, so for problem number 43, they tell us that cosine of theta is equal to 2 over 3. And they want us to write down what is sine of theta and what is tangent, the other two of the three. So I've just drawn a little right triangle like this. When we talk about SOHCAHTOA, what we need to remember is that we have an opposite, an adjacent, and the hypotenuse, right? The opposite is across from the angle theta. The adjacent is touching theta, and the hypotenuse is across from the 90-degree angle. You guys memorized that, right? You know it?
Yeah.
All right. So what is cosine? Well, cosine is the adjacent over the hypotenuse, right? Cosine of theta is the adjacent over the hypotenuse. So this is 2 over 3, isn't it? How do I find O? Yes?
You use the Pythagorean theorem.
We use the Pythagorean theorem. So what I'm going to do is I'm going to say, we write it a little different. It's actually O squared plus A squared equals H squared. So I'm going to have O squared plus 2 squared is equal to H squared, which is this. So I've got O squared is equal to 9 minus 4. What's 9 minus 4? 5. And then when I take the square root of both sides, I get that O is equal to the square root of 5. Right? Well, what's sine? Sine is opposite over hypotenuse. So the opposite is the square root of 5 over the hypotenuse, which is 3. Tangent is what? Opposite over the adjacent, so I've got the square root of 5 over 2. Is that what the answer was?
Yeah.
Now the only other thing that they say is that cotangent is positive. Okay? So now when they say cotangent is positive, this is with the triangle, but remember on the unit circle, I can draw 4 potential triangles, right? Because they all have to come back to the x-axis, so I could have a triangle like this, I could have a triangle from this point, and this point. Well, where is cotangent positive? Well, cotangent is the reciprocal of tangent, so where is tangent positive? Well, we said on our last problem that tangent is the opposite over the adjacent, so then cotangent of theta is the adjacent over the opposite. In fact, I'm going to go to another screen. That one looks a little cluttered. So if I come in here and I have my unit circle, well, actually, that looks horrible. Let's pull up an actual unit circle. So if I have my unit circle here, actually, no, let's just draw a circle and plug it in. If I have, oops. If I have an actual unit circle, we assumed and we drew our triangle like this, where we had the square root of 5, right? And then this was, what was this? 3 or 2? 2, and then this was 3. But that's just one reference angle. I could do the same thing over here. But now this becomes -2, right? Because if I look at this, this is x comma y, so this would be like 2 comma the square root of 5, right? Because in order to get to this point here, I have to go over 1, 2 units to the right, that's my x term, and then up square root of 5 units to get to that point. And then the radius of the circle would be 3. So if I sweep that radius around, I could get the exact same thing here and here. If I sweep it around again, I could get the exact same thing here, but now I have to go down negative root 5, and it's still negative 2, and it's still 3. So this point here is actually negative 2, comma, negative root 5. And this one here is negative 2, comma, positive root 5. And then lastly, this point here would be a positive x and a negative y. So now if we look at that exact same scenario, but now we want to talk about the values, we have, if we look at the unit circle, we have positive and negative values. What the textbook says is we're looking at when cotangent is positive. Well, we said that sine of theta is the opposite over the hypotenuse, but when we put it on the unit circle, it's really the y value over the radius. And cosine of theta is actually the x value over the radius, and then tangent is actually the y value over the x. And so they said we want to think about when cotangent of theta is positive or greater than 0. Well, remember that that is the reciprocal of this, so we're looking when cotangent of theta, which is equal to x over, my smart board doesn't want to work way down there. Basically, we're looking at x over y. Doesn't want to work there either. So what we're looking for is when x over y is positive. Well, here's my x, here's my y. Is the x over y going to be positive here? No, because I have one negative, right? So it won't work here. This won't work. We're not going to consider that triangle. X over y positive here? Wait, they're both negatives, so when you have two negatives, wouldn't they both be positive? So that would work. What about here? No. What about here? Yeah. So you could have written this answer. In other words, your sine of theta, now r is always positive. Okay? But it says cosine is 2 over 3. So cosine was x over r. So when they say cosine was actually 2 over 3, what are they telling us? That it's quadrant 1 because 2 was positive. Does that make sense? So technically, we're not going to use this one either. So we're only going to use the one that Mr. Adams did. Does that make sense? So I did all that explaining, not so much for this problem, but for the problems to come. So these answers are correct, right? These answers are correct the way they stand.